Pressure switches monitor water or air pressure. In a dry pipe system, Potter's PS series pressure type flow switches are used to monitor water flow, and supervisory pressure switches are used to monitor the air in the system. Pressure switches can also be used in wet pipe systems to detect water flow if the system has an alarm check valve. In this module, we will be reviewing what you need to consider when selecting a Potter PS series pressure switch, the features of Potter's most common pressure switches, and proper installation of the Potter PS series pressure switches. The most common Potter pressure switches are the PS10 and the PS40. Both switches feature a solid cast aluminum housing and a factory-installed neoprene gasket that ensures a NEMA 4 watertight seal when the proper conduit fitting is used. Potter PS series pressure switches have single or dual Form C contacts or switches and are system pressure rated at 300 psi. The PS series pressure switches have a unique single inlet design which incorporates the dual outlet air chamber to facilitate the independent adjustment of each individual set of contacts. Potter PS series pressure switches also offer a visual adjustment scale. The PS10 is used in both wet and dry pipe systems to detect water flow conditions. It may also be used as a supervisory switch depending on the supervisory air pressure level. Typically, the PS40 is used as an air pressure supervisory switch in dry pipe systems. This is a high-low pressure switch designed to detect a 10 psi increase or decrease in system pressure. The PS40-1 is factory set to detect pressure decreases at 30 psi, while the PS40-2 detects pressure increases at 50 psi and pressure decreases at 30 psi. The first step in the installation of Potter PS series pressure switches is to read and follow the instructions. As simple as this sounds, this step will make all the difference in the time and resources you spend to effectively complete this task. Never use pipe dope on pressure switch threads because it may cause a block in the pressure chamber. Use Teflon tape sealant on the male threads of the PS series pressure switch. In a wet pipe system with a variable pressure water supply, the PS10 pressure type flow switch must be installed on top of a retard chamber. A WFSR-F pressure switch with built-in retard can be used in place of the PS10 pressure switch. The pneumatic retard helps avoid false alarms in the event of water pressure surges in the water supply. A retard in the switch delays sounding the alarm for a specified period of time. If the water continues to flow for a duration sufficient to overcome the retard setting, the alarm will sound. If the water flow stops before reaching the preset delay, the retard will automatically reset. Water flow pressure switches must trip at 6 psi. Increasing the pressure at which the switch trips will not act as a retard feature. A retard chamber is a metal container capable of holding a volume of water. When a surge occurs in the system, the chamber partially fills with water and absorbs the pressure to prevent the switch from triggering a false alarm. Potter's PS series pressure switches should be installed with the NPT connection facing down toward the floor. And it's important not to adjust the trip point on a pressure switch used on a wet pipe system. Potter's PS series pressure type flow switches must be used on a dry pipe system. Vane type flow switches are not allowed because the paddles could be damaged in a strong surge that would occur when a sprinkler opens and water floods into the system. In addition, pressure type flow switches installed in a dry pipe system should not have a retard. The PS series pressure switch is installed on the alarm port of the dry pipe valve. Under normal conditions, there is no air or water in this section of pipe. Dry pipe sprinkler systems also require an air pressure supervisory switch. The PS40 is a supervisory switch that will trip if the air pressure varies by 10 psi from the normal setting. Potter's PS series air supervisory switches are factory set for a normal system pressure of 40 psi. If the system pressure is something other than 40 psi, the switch can be adjusted by turning the thumb wheel until the top of the wheel is even with the desired trip point. High system pressure supervision prevents the system from having too much air. Too much air in the system increases the time it takes to bleed off enough pressure to allow the dry pipe alarm valve to trip. Low air pressure is monitored to prevent accidentally tripping the system in the event of a compressor failure. Potter's PS series supervisory pressure switches should be installed in line with the Potter BVL bleeder valve. The purpose of the bleeder valve is to exhaust the pressure between the BVL and the pressure switch. This enables you to test the pressure switch without accidentally tripping the dry pipe valve. The use of a Potter BVL bleeder valve makes adjustments and testing a simple procedure. A test module with a gauge, a pressure switch, and a bleeder can be purchased fully assembled. This concludes Module 3 of the Potter Sprinkler Monitoring Training Program. In this module, we reviewed what you need to consider when selecting a Potter pressure monitoring switch, the features of the most common Potter pressure monitoring switches, and the proper installation of the pressure switches. If you have questions about a product or application and can't find the answer in this training module or in the instructions, please call Potter Electric at 800-325-3936.